Alright, let's start calculus with chapter 1, which should be a review. We could skip that, but I'm gonna go review a few things from chapter 1 first. Section 1.4, it's about exponential functions. So definition: an exponential function is of the form f of x equals b to the x. Notice that here the exponent is a variable and the base is a constant. The base is a constant. Exponent is a variable. Well, the base cannot just be anything. The base has to be either between 0 and 1 or greater than 1. The domain of exponential functions is all real numbers, and the range is 0 to infinity. There are two basic graphs of exponential functions. One that's of exponential growth. It has a y-intercept at 1. Exponential growth. That's if the base is greater than 1. And there's another basic graph of what we call exponential decay. It's decreasing. F of x equals b to the x. If the base is between 0 and 1, that's what the graph is going to look like. And it's decay, exponential decay. I have a handout that I put on D2L. Explains the difference between these two functions, exponential decay, exponential growth, all the properties of exponential functions. Please go over that in details. This is college algebra stuff. Let's look at a few examples. Page 52, number 2 from the text. Page 52, number 2. So I'm flipping the book to get to page 52. Okay. Page 52, number 2. It says, use the laws of exponents to rewrite and simplify each expression. So you have cube root of 4 divided by cube root of 108. We can write this as cube root of 4 over 108, which can be reduced to 1 over 27, which is 1/3. You know, stuff that we did a lot of college algebra. It's just a quick review. 27 to the 2/3. When you have a rational exponent, the bottom is the index and the top is the power. So it's 3 squared, which is 9. And just to remind you, if you have a negative exponent, that's in the reciprocal, which is 1/9. And if you look at D, I'm skipping C, 2x to the negative 2, also to the negative 3, x to the negative 3. You distribute the exponent, so it's 2 to the negative 3, x to the 6, and then x to the negative 3, which is x cubed. If you add the exponents, and 2 to the negative 3 is 1/8. And for f, you have have square root of a times square root of b over cube root of ab. You can write this as exponent power. That's as much as I could do. And then you could subtract the exponents, so you get a to the 1/6, b to the 1/6, which you could write as the 6th root of ab. So you can see that square root of a over times square root of b over cube root of ab is the 6th root of ab. Okay, number 12, page 52. It says make a rough graph y equals 4 to the x plus 2. Well, this is like the basic graph, b to the x or 4 to the x, but it's shifted 2 units to the left. 2 units to the left. So if you look at 4 to the x, it's one of the basic graphs that I showed you earlier that you have a handout of. 4 to the x would be something like this. It's exponential growth. If you shift it 2 units to the left, 0, 1, it's gonna be at -2, 1. If you check -2 in there, it will give you 1, so then the whole graph will shift 2 units to the left. So it'd be y equals 4 to the x plus 2. If you look at number 8, in number 8, page 52, it says use a grapher to show how graph changes relative to the change in the base. So if you look at y equals 0.9 to the x, y equals 0.6 to the x, y equals 0.3 to the x, and y equals 0.1 to the x. So what happens as the base goes down? Let's check. We have a grapher. We're going to use it. All right. So if you graph 0.9 to the power x, then 0.6 to the power x, 0.3 to the power x, and 0.1 to the power x. So the grapher will graph them in order. Oh, that's sorry. I'm gonna fix my window. Once it's done graphing, then I'll fix my window. So we'll do zoom 6 to do standard graphing. So this is the first one. 0.9 to the x, then 0.6 to the x. And you can see as the base decreases, the graph gets closer and closer to the y-axis. Okay. Alright, trying to fix this again. Next one is number 18, page 52. Page 52, part A, we have g of t equals square root of 10 to the t minus 100. It says find the domain of each function. Domain Since it's a square root, 10 to the t minus 100 has to be greater or equal to 0. 10 to the t has to be greater or equal to 100. We can do log. 10 to the t is greater or equal to log 100. So t is greater or equal to 2, because that's log 10 square, which is 2. So the domain is 2 to infinity for g of t for part A. Let's look at part B. G of t f sine of e to the t minus 1. G of t is sine of e to the t minus 1. Anything will work here because sine function goes from negative infinity to infinity, so the domain is all real numbers. No restriction. Number 29, page 53. Let's look at 29. It says a bacteria culture starts with 500 bacteria and doubles in size every half an hour. So initially at t equals 0, we have 500 bacteria. How many bacteria are there after 3 hours? It doubles every 0.5 hour, half hour. Okay, so I'd say B for number of bacteria. So B of 0, initially we have 500. B of 0.5, it doubles, so it's gonna be twice that. B of 1, after 1 hour it will be 2 square, it's 500. After 1.5 hour it will be 2 cube, right, because you're timesing it by 2 each time. B of 2, it's 2 to the 4 times 500. After 2.5, it's 2 to the 5 times 500. After 3 hours, it's 2 to the 6 times 500, which is 32,000 bacteria. Imagine, just after 3 hours, starting at 500, you end up with 32,000. Part B, how many bacteria are there after t hours? So B of t, so we need to find a formula for that. So this would be 500 times 2 to the 0, this is 2 to the 1, this is 2 squared, so this is it's 2 times 0, 2 times, because 1 is 2 times 0.5, and this is 2 times 1, and this is 2 times 1.5. I'm trying to find a pattern. This is 2 times 2, this is 2 times 2.5, and the 6 is 2 times 3. So B of 2 is 2 to the 2t times 500, or it's 500 times 2 to the 2t. That's how many bacteria you'll have after t hours. How many bacteria are there after 40 minutes? So 40 minutes is 2/3 of an hour. So B of 2/3, if you plug it in, it's gonna be 2 times to the power 2 times 2/3 times 500, which is 1260 bacteria. And then part D, you need to graph it, so you have your grapher, you can do it. And that's it for 1.4.